Hello everyone, welcome to day 4 of the challenge. Today let's continue. Try solving the yesterday's problem. Let's go to Coach F. And also let's open terminal. Generate to CP. Here 1 starter 2 star advance. Time complexity. Actually we are remaining 3 problems away to finish the 1 starter 2 star module. So let's open cooking machine. Let's close all these tabs. And our terminal. Let's open our problem mac.cpip. So here is the program we have written yesterday. So all of this looks so complicated to me, so let's remove everything and let's code from starting. Okay, I forgot to set the timer, so let's just set the timer for 60 minutes. Okay, timer is on. Let's open another terminal. Okay, now we are having our solution function here. I have read the question yesterday and we are taking input a and b for every test case, comma b, c in a and b. So basically here we are trying to reach the targeted number, that is b, when a is given, and b is always in the powers of 2. So we'll first, whatever the number they're giving, the a value will reduce a to 1 or 2, and then we'll just say log of b divided by log of 2, because b is always in the powers of 2, so we'll get the value, that is number of operations. Let's just say for now count equal to 0, and let's create a while b is not divided by a, not 2, say we will go on dividing a, we'll go on divide a, and we'll consider it as a single operation. We'll forget whether a is plus or minus for now. A is odd or even for now, and just let's divide it until we reach 2 or 1. If it is odd, we'll reach 1 here. If it is 2, we'll reach, if it's even, we'll reach 2. So after reaching, then we'll add log of b divided by log of 2. Okay, because when we reach 1, we need to do 2 into 1, right, the operation. So we are considering that the operation is also done, and let's just see out our answer. Let's just try run for this, for the operation 1 and 1. So for 1 and 1 is divisible by 1, so we'll not enter this loop. Count is 0, and count of log of b is log 1 by log 2. Let's take Python and let's just do log of 1 by log of 2. Okay, log is not different, so we need to import log import log, and then let's say log of 1 by log of 2. Log is not defined, we just imported log, right? Okay, let's take the help of the Google. Log 1 by log 2. What is the answer? Okay, let's say log 2 by 2. Log 2 is 1. Let's clear this. Let's say log 1 divided by log 2, and the answer is 0. So when we do here, we are getting 0 and 0 is added, so we'll get the answer as 0. Count is 0, right? So for this we'll get count as 0. Next 2 and 4. For 2 and 4, since 4 is divisible by 2, we'll not enter this loop and we'll directly come here. Log 4 by to the base, it's not log, it's log 2. We'll get the answer 2 because 2 power 2 is 4, right? So logarithm is opposite of exponential. And for 3 and 8, let's see what happens for 3 and 8. For 3, since 8 is not divided by 3, the remainder will not be equal to 0, then we'll enter this loop. We'll divide the 3 with the 2, so we'll get answer as 1, and we'll increase the count. Counter is now 1 and a equal to 1. Now since it's equal, we can divide 8 with the help of 1, so we'll not enter into this loop, we'll come here. So b is 8, right? So log 8 by log 2 is 2 power 3 is 8, so answer will be 3, and 3 plus 1 is 4. I guess it's working. Yesterday we were trying a lot, even, odd, plus, minus 1 by 2 by 2, and just those are all not necessary. You can just simply go on dividing the number a, no matter whether it is even or not, or based on the condition if it is it dividing b or not. If it divides b, then it means that we have reached a equal to 1 or a equal to 2. In both the cases, we'll divide it by log 2, because when you reach a equal to 1, which is odd number, you will be performing 2 into 1 operation. So 2 into 1 is 2. Now let's compile it. Let's close this and let's compile. Okay, we need to change into CP and Mac, and if we run it giving these operations as the value, okay, we got 0 instead of 1, we got 2, 4, 4, 2 and 2. Okay, log if it is 4, 16 percentage 4, it is divisible, so we'll not enter into the loop and we'll just come outside and we'll say log 16 to the base log 2, which will get 2 power 3 is 8, 2 power 4 is 16, so answer will be 4. So here it should be a. Okay, now what will happen if it is 1 and 3 and 8? For 3 and 8, let's compare. Let's run give one test case. 3, 8. You are getting garbage value. Why are we getting garbage value? Why are we getting negative value? Let's copy all. Let's paste it. I'm forgetting to. Okay, let's just have this thing as 2. Let's compile it. Let's run it, and let's take the test cases. Okay, now it's working properly, but okay, maybe the lab values are negative values, but that's not possible. So for first test case, it's running. When you get 2 and 4, you're getting answer as 2, but for you need to get the answer as 1, right? So this way is also not working actually. We need to think of some other way. How do you do this? We are given order if reaching to. Okay, let's try debugging this. Let's try this question for 10 more minutes, and if we couldn't find the answer, couldn't solve it, we'll check the submissions, because I think we have spent decent time on solving the question. So let's try to solve it for 10 more minutes. Okay, right now we are taking the values and we are saying if it is until it's divisible, just go on reduce the a value and increase the counter. Let's try run it for this test case. Actually we'll get the answer as 1, but since log of 4 by log 2, the answer is 2, so we are getting count as 2. How do you solve this now? If you just double it, it's enough, right? Should we do -1 there? But it's running very properly for odd numbers. Let's say one test case 3 and 8. Yeah, you're getting 4. Should we do all this if only if 3 is odd? Let's take another scenario 1, 5, and let's say 16. The answer is 5, because for 5 you can do 5 minus 1 by 2, which is 2. You'll get the answer as 2 after getting the 2. Now the count is 1. You can multiply it 4, count is 2, multiply it, count is 3, count, multiply it one more time, count is 4. You're reaching 1, 2, 3, 4. So this logic is not working for us. We are able to only solve few test cases with this logic. So how do we solve it then? Think. In yesterday's solution, if we go back, yeah, in this solution we are reading the values. After reading it, okay, let's run this for now. Well, we have to change the approaches if if the approaches are not working, right? So we got 0, 1, 4. This is wrong. Next one is 2, correct. Next 0, this is wrong, and this is also wrong. So first case is correct, second test case is also correct. When you come to the third test case 3 and 8, for 3 n is odd, so if n is not divisible by 2, we'll enter into this case. We'll call the n equal to odd of n and count plus plus. So initial count is 0, now count is increased to 1, and we are calling this a minus 1 by 2. We are returning it. A is actually 3, right? Yeah, it is 3. So 3 minus 1 by 2 is 2 by 2, which is 1. So 1 is written. Now 1 is also odd, but so it's not odd, right? Okay, if you get 1, then you need to multiply. Here you can write it as or n equal to 1. So let's just say if n equal to 1, then we call the even mul function and we'll pass the n to it. So this should be inside it. Set the if and n equal to even mul of n, and let's just say break. We need to break it. We need not break it, we should do count plus plus. Okay, now let's compile, let's run for one test case 3,8. It's odd, even multiply, even multiply, even multiply. Very good, 4. It's working for this test case. Let's run one more test case, 4 and 16. It is 2, perfect. And one more test case, 4 and 1. You got answer 0, we need to work on this. And one more test case, 1 and 4. You got 2, perfect. So if we go and like compile it and a dot out, we'll copy these things, paste here. You got 0, 1, 4, 2, and you got 0, 2. 1, 2, 3, 4, 5, 6. We are getting 6 output for the 6 test cases. Yeah, very good. Only test case not running is if a is greater than b. If a is greater than b, we wrote, I mean k, n is greater than k. We haven't written anything. We have only written for n is less than k and equal to k. Okay, we need to write for greater than k. Let's say while n is greater than k, what you have to do? You need to divide the n and increase the count. N equal to n by 2 and count plus plus. Now at one point n has become less than k, and this while loop will run. That's it, right? In this while loop, if n reaches less than k, and that is 1, we'll just say if n equal to k, should I write this thing here? Because we can compare. Let's, instead of we'll just say cout count instead of 0, because here we are changing the count value, right? So now if we compile this, copy everything, paste here. Now we got 0, 1, 4, 2, 2 and 2. Wonderful. Let's remove all these statements. Very good. That's pretty long code. I guess we have hard coded everything. That's why it's so wrong. So since we hard coded it, I'm doubting whether it will pass all the hidden test cases or not. Let's see. Because the answers correct for given sample test case and sample input and output. Now we are compiling. Currently running test case 0, 3, test case number 6. I hope it will get submitted. It's a wrong answer. Only first test case and the test case 7 got submitted. Rest of them all got failed. what could be the mistake? Let's open our terminal and try giving our own. We have completed our 10 minutes of time. So let's check the solution. Let's check the solution written by Priyansh 1008. So his code is also pretty big here. So he also given the approach explanation. So let's just see what he have done actually in the code. He has taken a function with the return type of true or false, and he's taking int if n is greater than 0 and int c equal to, he took a variable and he took the remainder of the n, and if n is not, c is not equal to 0 and n is not equal to 1, he's returning false. So he gave his approach that it is to check if the number is of power 2 or not. So he basically took a function to check whether the number is in the power of 2 or not. Okay, and if this thing is not executed, and if he came out of the while loop, okay, he's actually dividing n equal to n by 2. So he's go on dividing, and whether if he doesn't reach c not equal to 0, okay, if he reaches c equal to 0, then he'll return true because it is the power of 2. Okay, very good. Next, inside while loop, he is taking while not is a. So is a will give true if it is a power of if the given number is power of 2. If it is not power of 2, okay, if it is given if it returns false, that means it is not the power of 2. Then not of false is true, then he will enter the if. Inside if a equal to 1, he'll just break, and the whole while loop will not get executed. He'll check if b is greater than a, and he'll check if b is less than a, and then he's printing the counter. So if a is not equal to 1, then he is checking if a is divisible by 2. If it is not divisible by 2, if it is odd number, he is doing a minus 1 by 2 and increasing the counter. If it is an even number, he is doing a equal to a by 2 and increasing the counter. Okay, if a is basically not the power of 2, he is doing all these things. He is handling for all the odd numbers, and for the numbers where a is not the power of 2, for example like 6, 10, 12, for those numbers which are, he's doing this, he's just reducing and he's increasing the counter. After coming out of the while loop, he's checking if b is greater than a. If b is greater than a, then he will multiply a with 2 and increase the counter, and if it is equal to b and a are equal, will break the while loop. And if b is less than a, until a is greater than b, he will divide it and he will increase the counter, and he will say if b equal to a, break. That's it. Okay, now I understood what he is trying to do, because these few of the things are things I have tried to do. Like if a is greater than b, we need to divide. You can see it here. We have used the 2 while loops. He also used 2 while loops. He written code for a greater than b, that is n greater than k. So when you try for certain amount of time and you couldn't get the solution, and when you go look the solution, check out the solution, you can understand it much faster than if you directly check the solution. Okay, now we need to make some changes in our code. Firstly, we need to check whether the given number is, whether n is in the power of 2 or not. Let's have this function, it is useful. Let's write an if inside it. If n equal to k, we need to break. That's it, right? Yes. And we'll write a similar function, and for where n is less than k, we need to multiply n. We'll cut all this thing and we'll paste at the bottom of the code as he has done. Okay, giving proper indentation. Now we need to change this part of the code. We need to run our code only for the values which are not power of 2. If they are power of 2, we have no problem with them. We'll just multiply them based on if they are greater than. If they are greater, I guess we need not write the if right here, because if it is false, if this statement is false, then we'll automatically come out of this while loop. Here, if b is less than a or a is greater than b, both mean same, so we need not write this if and else block here. And our function is, I guess we can write the function. We'll remove all these functions, we are not using them anyways, so we'll use a bool is function which takes a value int n, and let's say int k equal to log of n by log of 2. If this logarithmic value, I'm trying to somehow use logs and reduce this function. And we'll check if let's take a variable sum equal to 1 for int I equal to 1 to I less than k, I plus plus, we'll multiply sum with equal to 2. If sum is equal to n, then we'll return true, else we'll return false. That's it, right? Because I'm guessing if this thing gives a value for 4, let's say 4, if it gives 2, and we'll run this function for int I is equals to 1, we'll multiply with the 2, and for int I equal to 2 also, this function will run, right? No, it doesn't run, so we need to have equal to here for 2, and we'll multiply it one more time. If the sum is equals to n, return true. So let's just check it. Let's for now let's remove all this code. Let's check is cout is 4. Okay, I have pressed Ctrl comma by mistake instead of shift. Now print the 10 new line. So, okay, we are taking a lot of time. So now let's just compile and let's run. Let's give one test case and let's pass in the n value as 5 and 10. You can see we could do two things. This thing has been executed. Yes, we got 1 for it. For e is 4, 1 is written. That means true is written, I guess so. Okay, let's just say cout a. Now let's just compare. Now let's give same values. Yeah, a is printed, and that means true is it's returning true. For me, this function I'm able to understand this function quite easily rather than this function, so it's up to you. Now my point is not to copy the code and make modifications. My point is to understand the code and write it according to my style. Okay, now here we'll enter into the while loop. For every number which is not the power of 2, that means for the values like odd numbers, we need to deal like numbers like what is happening here. Okay, 3 and 5 and 8. Okay, it is 6 and 12, 14, and numbers like 13. All this, to deal with all these numbers, we are writing this while loop. While loop not a of, it's not is, right? Not is of n. So inside this, to deal with numbers, if they are equal to 1, then we'll just break it. Will not execute this loop, and that a1 will be taken care here at this part of the loop. And if okay, now if it is not divisible by 2, that means all the odd numbers will perform the odd operation, and for all the even numbers will perform the even operation. So if n is equal to 1, we'll just break it. If n for n alright, so if it is an odd number, then we will say n is equals to n minus 1 divided by 2, and we'll increase the counter. Else, that means it's an even number, n equal to 2 into okay, we need to divide it, and we'll increase the counter. I hope that's it. Let's run the code. Let's pass all the yeah, it's running fine. We are able to solve the sample test input and output. Let's just submit it and check whether the test cases are passed or not. Submission is queued. Running test case number 7. Yeah, it got submitted. Well, I was lacking clarity in solving in this question. Like clarity, like how to deal the numbers. Okay, for example, if it is greater than k, and this I got the clarity to do this, but I didn't get the logic to solve this problem if the numbers are not the powers of 2, which includes both even and odd numbers. Anyways, we solved it, and we are having just 25 minutes. let's try solving these two questions in the 25 minutes. Let's open our terminal or term, and this question is push 7 power dot cpp. So he says Pushpa has entered the chief land and wants to publish. Okay, I have solved this question already, so I guess it will be easy this time. Here Pushpa Raja here too. Cheflan has n towers where the height of the ith tower is hi. To establish Pushpa Raj, Pushpa does the following. Initially, Pushpa chooses any tower and lands on the roof of that tower. Let x denote the height of the tower Pushpa is currently on. Then Pushpa can land on the roof of any tower j such that the height of the jth tower is x plus 1. Let I denote the index of the tower on which Pushpa lands. Then the height of all towers except tower I increases by 1 after each jump, including the initial jump. To establish Pushpa Raj, Pushpa wants to land at the maximum height possible. Determine the maximum height Pushpa can reach. So here it says he can jump from tower 1 to tower 2, but when he jumps from the tower which he jumped except that tower, all the tower values increases by 1. That means if Pushpa, let's see for the test case 1, 4, 1, 2, 1, 3. If Pushpa chooses to start from tower at index 1 with height of 1 unit, then the new heights will be 1, 3, 2, 4. So this is just 1. This will be 3 increased by 1. This will be 2 and this will be 4. He can then jump to the third tower with height 2 units, which from 1 to he can jump to tower 2. Now when he jumps to tower 2, the rest of the tower's heights will be increased by 1, that is 2, 4 and 5. Pushpa is unable to make any more jumps. The optimal way to in this case is to take an initial jump at tower 4 with height 3. Then maximum height Pushpa can reach is 3. So in this optimal way, from initial jump at tower 4 at height 3, this is the tower 4 where he will take the initial jump and the maximum height he can reach is 3. And in here there is only one tower, so Pushpa can reach the maximum height of 2. So they are giving you an array of numbers. So let's open our code text editor and let's say array. Now we are reading an array of numbers. We need to find the maximum height he can jump. How can we do this? If we sort, okay, we are given 1, 2, 1, 3. So if we start from 1, let's just find the maximum number and then we will find I guess maximum number is the answer. If it takes let's say if the given consecutive numbers like 1, 2, 3, 4, 5, if it jumps from tower 1 to tower 2, then it becomes 2, 2, 3, 4, 5 and 6. Now he cannot make any progress. So basically we need to jump to the maximum number. Let's find the max. Equal to 0 for int I equal to 0, I less than n, I plus plus. Max is equals to, if any number is greater than max, then max will be equal to that number, or else it will remain as max itself. Now let's compile Let's run. Let's give 2 4 and 2 1 3 1 and 2. Okay, we are not printing the output. The output is max. Let's print. Let's run. I'm guessing it is the maximum number itself. The initial jump will be on the maximum number. But if they're consecutive numbers, then what? Like 5 5 5 5 5. If he jumps from 5, yeah, if they're consecutive numbers, then our approach will fail. Because let's just say the given output is like this, 5 5 and 5. So if from initial tower he will jump to this tower, then the values will become 6 5 and 6 6. Now from this tower he can jump to this tower back, because the difference is only 1, so it will be 6 6 7 7. From this 6 tower he can jump to 7 tower, so the values become 7 6 7 and 8. Now from 7 he can jump to 8, so the values will become 7. Okay, this will become 8 6 8 and 8. So the maximum height he can reach will be 8. So initial value and the values that are repeating. Okay, I'm guessing it should be correct. Like let's just say he's given 1 1 1 and 1. Now I'm guessing the answer is will be 4. Maximum height, let's say from tower 0 to will jump to tower 1, so it will become 2 1 2 and 2. From tower 1 to will jump to tower 2, I am speaking in terms of indexes, so this will become 3 1. Okay, this will become 2 and this will be remain 2 and this will be 3. Now from tower at index 2 to he'll jump to tower at index 3, and that will become 4 3 2. Okay, this will become 3 and this will become remain as 3. Now from this tower he'll jump to this tower, so then the answer will be 4 4 4 and 4. So initially I thought the answer is 4. Did I say 4 or 3? I forgot. So my approach is like we'll find the frequency of the highest number, then we'll add, then the frequency is the answer. So if you have 2 here, the maximum value is 2, right, and its frequency is 1, so answer is 2. 2 plus its frequency 3, so I'm thinking the answer must be 3. So let's start from, he will jump from this tower to this tower, then the answer will 1 okay 2 1 2 3. Then he will jump from this tower to this tower, and the answer will be 3 2 2 3 4. Now from this tower to this tower, 4 3 3 4 5. It doesn't work in that way. Then what is the solution? We still have 16 more minutes left to solve this question. We are jumping from I'm thinking for the solution. How can we solve this? It's not the maximum number way. It's should we hard code it like like we'll take the number. Oh no, but it shouldn't work in that way, right? It will not work in that way. Hmm. I couldn't think of any solution. We cannot hard code it. Like we cannot take a number 1, then we'll increase the rest of the numbers, and if any number is near to the, if we'll search for the number, we need like 1, right? If any number whose difference is just 1, then we can jump. Can we do that? No, we cannot. Actually, I have solved it right already, so let's check my solution to this question. How did I do this? I created a map frequency, then I just read and counted its frequency of all the numbers, and then I have added the first and the second. I have added the key and its frequency, and I have subtracted the 1 from it, and I took the maximum of all of them. Okay, so I was doing like, so I'm not understanding here. So what was I speaking? I was saying, let's give 1 1 1 and 2. Since this is 1 1, and so 1 plus its frequency is 1 2 3 4 4, which is equals to 5. That is the maximum value. 2 plus 1 is equal to 3, right? So out of this both, 5 is the highest, so that's how we'll get the answer. It makes sense if I'll run my head around it. Like if we are jumping from 0 index to first index, then it is like 2 1 2 2. From first index to third index, it's like 3 2 2 3. Now from second index to third index, it's like 4 3 and 3 and 3. And we can jump one more time, 4 4 4 4, from last number to this number, right? That's it, I guess. To the pillar we are jumping, it will not change. The rest of the things will be changing. So it should be 3, right? It should be 2, because now this will not change. Now from here we are jumping here, so it will remain 3, and rest of the numbers will change. From here we are jumping to 4, so all these values will increase. So our answer is 4 for this test case. And 1 plus its frequency minus 1. Okay, we are doing minus 1, right? For that's the reason. So let's just code it one more time by ourselves. We shouldn't save it. Let's take a map int comma int frequency, and while reading itself, we'll calculate the frequency of a of I and plus plus. Okay, yeah, very good. Now let's say for auto I for the map frequency, let's just take a variable int count equal to 0, and count we need to add the, let's take int value equal to I dot first plus I dot second minus 1 if count is, let's just use iterate operator, count equal to, if count is greater than value, if it is true, then the count will remain count. If it is false, then the count value will get val, and then we'll just print the count. Let's compile our push 7 pa. Copy, paste our test cases, and we're getting 3 and 2. Let's copy this, let's paste it here, and let's let's copy and let's paste it here. Let's submit. And 10 more minutes are remaining. Currently running test case 2. Actually, I couldn't solve this question. I couldn't remember the solution. I have took the help of myself since I have already solved it. Now let's see, reversal sorting. By the question itself, it sounds like the question is based on sorting, right? So let's sort dot cpp and let's clear it. Now let's read the question. Jeff is deriving wide ways to sort his array. Currently he is trying to sort his arrays in increasing order by reversing some of his subarrays. To make it more challenging for himself, Jeff decides that he can reverse only those subarrays that have some of its elements at most x. Soon he notices that it might not be always possible to sort the array with this condition. Can you help the Jeff by telling him if the given array can be sorted by reversing subarrays with sum at most x? More formally, for a given array A and an integer x, check whether the array can be sorted in increasing order by reversing sum of the subarrays such that the sum of all elements of the subarray is not at most x. Okay, let's read this one more time. More formally, for a given array A and an integer x, check whether the array can be sorted in increasing order by reversing sum, possibly none of the subarrays, such that the sum of elements of the subarrays is at most x. Okay, this is also, even this question is also based on our arrays, so we can use our snippet array, and we are reading here our test cases, and we are calling our solve function, and we are also reading the size of the, and we need to read our x value also. So let's create our variable x, let's read x. Okay, now they are given 1 2 3 4, so it is saying 1. The array is already sorted, so we not make any operations. Okay, now here 2 and 1, so we cannot sort it because any subarray will take its size will be greater than 1. I mean, if sum is will be greater than 5 and 7. Okay, here we can take a 3 and 2, we can sort it. Next again we can take 2 and 3. I mean, if it is sorted, you'll get the point, right? 2 2 3 3. If we select first two numbers, it will be 2 and 3, 2 3 3 2, and if we sort 3 2, then we'll get 2 3 3 and 3. Now the array is sorted, so it is an S. Okay, I'm thinking like if we take the maximum value of the array and the second maximum of the array and both of the sum is less than the k value, then we can sort it. If not, we cannot sort it, because whatever the array is, we say like 8 4, then we are having 10 and 12, 10 and 12 also. Let's we are having 15 and 16. So we can sort these two. Okay, all this part is sorted. So 8 and 4, we can select this subarray and we can sort, or we can take all the subarrays and we can sort them. Yeah, if the size is, or if only we can select this subarray and to sort it. If not, we cannot sort it, right? If the size is given just 20, we cannot choose these things, so these two things will be remain unsorted and the whole array will be remain unsorted. So for now, we'll sort the array directly. Sort a plus n, and we'll take the last two numbers. Let's say in sum equal to a of n minus 1 plus a of n minus 2. We'll take both of them, and now after taking them, if sum is less than the value of x or equal to the value of x, we can have equal to at most x. At most, in the sense, we can have equal to, I'm guessing so. Cout, you can, the output can be case sensitive, but still we'll go in this way, else we'll cout. No, I hope that that's it. Maybe it may not be that easy also. Out. It's waiting for the input, so let's give our input here. No and yes. Okay, we need to check if that is already sorted or not. So if, how do you check if it is already sorted or not? We'll take a for loop. Okay, we'll write a function then, and the function is it returns boolean and it says already sorted or not, or it can just say return int already underscore sort, and it takes an array and the size of that. Inside this, we'll take a for loop int I equal to 0, I less than n, I plus plus. If a of I is less than a of I plus 1, then we need to go here. We shouldn't go out of the bound, so let's just say n minus 1. Then we'll do nothing. If else, then we'll say return 0, that means it's not true. Else 1, that means it's true. So let's just call, before doing anything, let's just call if already sorted the array. If it is true, then we'll print s and we'll return. Okay, if it is not sorted, we'll sort it and we'll take the last two numbers sum, and if it is less than the given x value, then it can be sorted. If it is not, it cannot be sorted. Let's sort. Let's take these test cases and paste it here. Now we got the right answer. Let's copy everything, paste here, and let's submit. Submission is queued. We are running test case 3 6. I hope it gets submitted. It's fail. Okay, everything is wrong answer. Everything. So where is my logic? Okay, based on my logic, let's run this question one more time. Let's just say variables like, for one test case we are having 5 values and the value given is 12. So now we can give 2 6 5 8. 6 and 8 values is increasing greater than 12. By the way, timer has been ended, but let's solve this. So now let's give one more value 1. So answer should be no, right? Because sum of 6 and 8 is greater than less. So we cannot select those numbers greater than 12. So we cannot select those numbers and we cannot sort that part of the array. But if we give the value which is 20, then we can easily sort the array, because we can select 6 and 5 and then 8 and then 1 and then sort the whole array, and then we can select the 2 and the last number or the next number to 2, that is 1, and we can sort it. So what am I like? Is it the integer, the data type? Because they are saying all this 2 to the power of 10 power 9 plus 2 to the power of 10 power 9, it is 4 into 10 power 9. Okay, let's just say LL and change everything to long, and we'll copy this code, paste it here and submit. Did we change everything to long? Okay, we didn't change this to long, so we'll get an error there. We changed to this to long, this to long, and even some also to long. Yeah, I know we'll get the error. We got the error. Let's submit it again. Submission is queued. Running the test cases. I hope that's the only mistake. It got failed. All the test cases are wrong. So where am I? What is the point I'm missing in my logic? That's it, right? We cannot take any two numbers whose sum is greater than the x value. So we cannot sort. Only if it is less than x we can sort it. Or else let's just do it with the for loop, where we'll be checking the numbers, and if the sum of the numbers is greater than x, like instead of sorting, we can like do it for the adjacent elements. It's the same thing, I guess. I guess you got the point. Like, we'll take the for loop and we'll go checking the adjacent numbers, and if the sum is greater than x, then we cannot sort those two numbers, and if they are misplaced, right? One second, but if they are okay, we need to check this condition also. If they are not misplaced, then you need not do all this, right? So like let's say if we need not sort, then we need not take the maximum elements. Let's just say for int equal to 0, I less than n, I plus plus. If the numbers are in correct order, if a of I, if the first number is greater than the second number, okay, again we need to not cross our limits, so that should be n minus 1. If it is not, yeah, this is the only problem. So if it is not, if they are reverse, it doesn't matter if the sum is greater than or x. Only if they are in this way, where if the first element is greater than second element, and if their sum is greater than x, and if the sum is greater than x, then we'll just print no and we'll return. Okay, else we'll be doing nothing. And I guess we need not even, this line is not necessary. If it didn't get returned, then we can print yes at the end, right? Yeah, we can print s at the end. And here, if it is already sorted, then it goes into this loop, and this condition will never be reached. So we will never go into this if loop, into this if condition. This for loop will run, and yes will be printed. Okay, we need not have this e. Okay, now let's remove already sorted, and also let's remove this already sorted function. That is quite unnecessary. Now let's test my logic. Copy all this thing and paste here. You got yes, no, and yes. Yes, it's working. Let's hope it gets submitted too, because I have reduced its complexity. For me, most of the times, as I have seen, when I reduce the complexity of the code, when I turn it simple, it will get submitted. So we are running test case number 3, 6. Will test case number 7 running will be displayed or not? No, it is not displayed, and we got our wrong answer. So what did we miss here? If the sum of any two numbers is greater than 0, then we'll print no, shouldn't be greater than 0, right? Output is case sensitive. We can print yes or no, it doesn't matter. We have taken even LL long, so even data type is not a problem for us. So what are we missing here? I'm not understanding what are we missing here. It's the same code. We are reading the x value. Also we are traversing through the array, and the first element is greater than the second element, it's not in increasing order, right? It will be decreasing order because the first element is greater and the next element it decreased, so it is in decreasing order. Time expired at 12 now. Okay, it's been 10 minutes extra. Let's compile it one and let's check it one more time. It's working for these test cases. For the sample, yes, no, yes. But when I try to submit it, it's not working. Submission queued. I didn't even miss the new line characters, I'm having them. So what is the problem? It's a wrong answer. What is the mistake we are doing? Yeah, we'll print it and we'll return. Attachment will come here and we'll go again. I will call the solve function from fresh. So there is no mistake here. And we are exiting. We have written cout, yes, after the for loop itself. So we need not bother about the else condition. We are imagining that it will get sorted if they are if that value will be is less than x, then we'll choose that sub array and we'll sort it out. So we need not bother about that part there. Okay, let's try solving this. We'll continue solving this question from tomorrow. For today, that's it. We have solved 2 questions for today. If they are greater, then and if the sum is greater, then we'll directly print. No. Should we have brackets here? I guess it doesn't. It's first addition will perform, then we'll have x. It somehow feels like answer is correct. I don't feel I have missed anything anywhere. Shall we check the submissions? Let's check the submissions. And view all submissions. Let's see what. Okay, here we have. It's my submissions. Let's check the solution, which is in C++ 17. So here he's saying he's reading the test cases, reading the n value, x value, and for every he's directly reading instead of creating an array. He's directly reading the I values. If I value is greater than mx, then he's basically taking the greatest number, and if it is not greater, greatest number. If I is less than okay, if we get any number that is less than the maximum number, then he's adding both of them and he's checking if it is greater than x. Okay, so he's saving his greatest number, and I'm not saving my greatest number. But okay, I'm only checking my greatest number and its adjacent number, right? So if there is 5, 6, 9 and 12 and again 5, 6, somewhere it's 13, so I'm checking only this. Okay, if it's 12 and 9, and if these two sum is less than the x value, we can sort it, but we are not checking. And these two sum is also will be less than, let's say if they are given like 30, x is equals to 30 t. Okay, what is 13? Let's say not 30, let's just say let's make it to make this thing, we'll remove that 9 from there. Let's say he gave the value as 20. Here we can change this to, and here we can change this to, because the values are not if we add them, then the value is less than x, but for 12 and 13 it doesn't work. So that's what I have done. I have taken the greatest number and I have taken the less number than that after sorting. My first logic was that, and he's saying then he'll break, he'll come out of the while loop. He's saying if cout the result is greater than yes, if it is true then we'll be printing yes, if it is false then we'll be printing no. If n is greater than 0, cin dot ignore max size comma, and I don't understand this line. Okay, that's what he's doing. Let's see another solution. Okay, why is everything in C++ 17? Let's see this solution written by Nidhi in C++ 14, and she's taking a vector reading values f1. If this seems like my logic. If f of a of I is greater than a of I plus 1, and if the adjacent number sum is greater than x, then f equal to 0. I guess it's been a long time recording this solution. Let's just compare what's a command we have written. After reading, I'm saying for int I equal to 0 and I less than 1, a of I is greater than, and a of I plus 1, a of I plus a of is greater than x, then f equal to 0. That's what I'm saying now. No, I'm just printing no and I'm returning from here itself. Then C is also swapping them. You need not swap them. Okay, she is also sorting them, but I'm nowhere bothered about sorting. And then if f equal to 0, then she'll print s. Why is it s? What is he asking? For each test case, output yes if Jeff can sort the array using a finite number of operations, else print, else output no. If it is greater, if it is 0, then we need to print s. It means we cannot sort it, right? If it is 0, we cannot sort it. We cannot select those numbers. And we cannot sort those numbers. Let's just turn this into s. Just checking. I guess even the test cases will fail here. I mean the sample input output test cases also will fail. Why am I trying to compile that file? Did compile. Let's take our test cases here. Let's just print it. It says no as no, as just reverse. It can't be like that. Okay, we'll solve this thing tomorrow. This question tomorrow, as we have solved yesterday's questions today. So for today we have just solved 2 questions, and we attempted the third question. If we solve that one thing, we would have finished this module. No problem, we'll finish this module for tomorrow. And as usual, you can get access to the code if you want. It will be available in my Git repository. And thank you.